Good afternoon, class. Here's elementary statistics, practice test number 4, module 4, covering chapters 8 and 9. Here's chapter 9, inferences from two samples. Reminding you of the pledge, I pledge on my honor when we take the exam. I will neither give nor receive unauthorized assistance, so on and so forth. You may use formula sheet, tables, and a graphing calculator. Among 843 smoking employees of hospitals with the smoking ban, 56 quit smoking 1 year after the ban. Among 703 smoking employees from workplaces without the smoking ban, 27 quit smoking a year after the ban. Is there a significant difference between the two proportions? Use a 0.01 significance level. It's important to understand again, this is a word problem, application problem. Let's write the given. Obviously, we have two outcomes. It's BD, binomial distribution. Okay, you either quit or you don't. So it's a binomial distribution. We have two groups, two samples. So 843 and 56. What are they? If we go with the first group being this one, N1 is 843, X sub 1 is 56. The second group, N2, and sub 2 is 703, X sub 2 is 27, alpha is 0.01. So that's the given. We write the given. And now we're going to move on. We need to do the test of hypothesis, but before we do that, we have to look at a couple of things. First of all, P1 hat is X sub 1 over N sub 1. So the ratio of these two numbers. Okay. P2 hat, it is X sub 2 over N sub 2, the ratio of these two numbers. So we need those. And we use a lot of decimals. Also, P bar, the pulled proportion, is X sub 1 plus X sub 2 over N sub 1 plus N sub 2. That means add 56 and 207, put it in the numerator, 843 and 703 in the denominator. And if you have P bar, you also need Q bar, which is 1 minus P bar. Okay, 1 minus P bar. Just like Q is 1 minus Q and so forth. And the reason we need that is for the test statistic. Having said that, we want to go with the test of hypothesis. H0 P1 minus P2 equals 0. And then, is there a significant difference between the two? H1 P1 minus P2 is not equal to 0, which makes it a two-tailed test, which makes it a claim. Now, one thing I want to make a point of, you could write here P1 equals P2. Here, P1 is not equal to P2. Which one do you write? Just the way they wanted. Just be consistent. Don't mix and match. Okay. The next step is test statistic. The formula is P1 hat minus P2 hat over the square root of P bar Q bar over N1 plus P bar Q1 over N2. That's why we did all those calculations. Now we just have everything we plug in. P1 hat minus P2 hat over the square root of P bar Q bar over N1 plus P bar Q bar over N2. You put it to the calculator. You get the test statistic, which is a z-value, by the way, equals 2.4319. Remember, with the binomial distribution, we are approximating it with a normal distribution. So we never go to t. Having said that, the critical value comes from the choice of alpha, which is 0.01. It is a two-tailed test. We do the drawing. And we need to see from the two, this is negative 2.575, this is positive 2.575. This number either comes from the table or technology. Test statistic of 2.4319 is way into the non-rejection region. It's between the two numbers. Therefore, you fail to reject the null hypothesis. So every calculation is about this piece. That's it. Now we want to elaborate, and therefore we're going to go with the concept of a claim. We look at the first step. We fail to reject the null hypothesis if we are rejecting not rejecting the null hypothesis, we are rejecting the alternative hypothesis, therefore we are rejecting the claim, therefore the claim becomes false. And we restate as follows: there is not a significant difference between the two proportions, however you want to put that. And we're done with that, but let's continue using technology. And for that, we would use two proportion z-test. I hope you see what we've done here is that instead of one group, we are dealing with two groups. That's the difference. So two proportion z-test. So when we put that in, it's going to ask us for x sub 1, n sub 1. It's going to ask us for x sub 2, n sub 2. And we are going to make a decision which one do we use for P1, okay, not equal to P2 less than or greater than. So in other words, this one, okay. So that's why I said you may use this one, you may use this one. Technology uses that one, it doesn't matter. Understand they mean the same thing. So you calculate, what do we get? Let's take a look at everything that we get. Number one, the test statistic, it's been calculated with a lot more decimals. P1 hat, again, calculated with a lot of decimals. P2 hat, calculated with a lot of decimals. P bar, calculated with a lot of decimals, of course. And now, what is this? The p-value. The p-value for us is the area to the right of test statistic, which is this much times 2 because it's a two-tailed test. So this is the p-value 0.0, let's say 1.5, which is much larger than alpha of 0.01. Same decision, failed to reject the null hypothesis. So it's very straightforward. Hopefully everybody's okay with that. Now, let's look at the same question, and we are going to construct a 99% confidence interval for the difference between the two proportions. And these are all the information we have from the previous page, that some of them are given, some of them are calculated. Please understand that alpha of 0.01 for test of hypothesis, two-tailed test, corresponds to 99% confidence interval. So having said that, we are interested in P1 hat minus P2 hat plus minus E. So what is the formula? And this is another way of writing it. P1 hat minus P2 hat minus P minus E or plus E, and P1 minus P2 is in between. Either one. Which one do you use? The one that they ask you. Having said that, P1 hat minus P2 hat, we have the two values. P1 hat and P2 hat, we calculate that, and we get 0.028022. The next one is E. The formula for E is Z alpha over 2, which is the same Z that we had in the previous page. And square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Again, the fact that this is a 99% confidence interval, this is a two-tailed test with alpha 0.01, they give us the same Z, so we don't have to look it up. We use the same Z, namely 2.575 here. P1 hat, Q1 hat, N1, N2, everything is here, plug it. And of course, after you put it into calculator, this is what you get, which means now this number, P1 hat minus P2 hat, plus minus this number, which is E. Okay. So subtract from it, add, and we get the following. Negative to positive. Negative doesn't matter how small or large. Negative 0.0000878. Positive 0.05692. P1 minus P2 is somewhere in between. And as you notice, one side is negative, one side is positive, which means it contains 0. Because the confidence interval limits contain 0, there is not a significant difference between the two proportions. Failed to reject the null hypothesis. If both of them are negative or both of them are positive, then we reject the null hypothesis. Having said that, again, technology. So I calculate the confidence interval to proportion, and we put the same information, x sub 1, n sub 1, x sub 2, n sub 2, confidence level of 0.99. It does this, and notice this and this one. Now, please understand the left side means negative 9 times 10 to the power of negative 4. The right side is 0.05692. Now, this is different than this one because of the fact that over here, we stopped at some point, but over here, they use a lot of decimals again, just to make sure we understand. This means minus 9 times 10 to the power of minus 4. The decimal is here, remember, and you have to move it this way. 4 decimal. So you have after that 9, you put 3 zeros. So that's why it's the same as this one. If you stop here, you have to change it to 9, and it becomes identical to what you see. So that should be pretty straightforward, everybody. All right. Company A claims that its yogurt cups contain on average fewer calories than that of a competitor. A sample of 50 such yogurt cups of Company A produced an average of 141 calories per cup with a standard deviation of 5.4 calories. A sample of 40 yogurt cups of a rival Company B produced an average of 144 calories per cup with a standard deviation of 6.3 calories. If the calories of the yogurt cup for Company A and Company B have different variances. So we're going to check that, and we're going to use a 0.01 significance level. So that means, of course, alpha. So let's write everything in the following manner. Let's come up with a table, N, Company A, Company B. For example, N, we're going to call it N sub 1, 50, N sub 2, 40. X bar, we're going to put X1 bar here, X2 bar here, and this is X1 and X2 bar because it pertains to the sample. And the same thing here, S1 and S2, the standard deviation. So we write this out. By the way, if the carriers of the company A and B have different variances, use a 0.01 significance level test. I want to make sure everybody understands there is a reason that we use that. That gives us a specific test statistic. So there are two ways to approach this. And generally speaking, they don't have to tell us this one to approach it that way. Okay. So having said that, alpha is 0.01. And so H0 mu1 equals mu2. What is H1? We are claiming fewer, so H1 mu1 is less than mu2. This has got nothing to do with H1, okay? This has got to do with test statistics. So H1 mu1 is less than mu2, which makes it a claim and makes it a left-tail test. Now, the effect of this is this formula, everybody. T is x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. And by the way, this uses, let me just explain a couple of things. This one, you may use mu1 minus mu2 equals 0, and that's what it goes here. It always comes from there. So I want to make sure you understand that. So having said that, we do the math, and we get the test statistic T equals negative 2.3901. And it's important to understand it's T, not Z, because sigma is, of course, missing. So alpha is 0.01. And the way the degrees of freedom works, the formula is pretty complicated. So when we have limitations, we use smaller of the two, meaning smaller of n1 minus 1 and n2 minus 1. This is 50 minus 1, 49. This is 40 minus 1, 39. So we use 39. This is again for the limitation. I will show you the formula that is pretty complicated. So let's come up with the t value, and let's do the drawing. As you can see, Here's the critical value of negative 2.426. Alpha is 0.01. Test statistic of negative 2.3901 is way into the non-rejection region. Don't reject H0 or fail to reject H0. And so we go back to this one. If we are not rejecting this one, we are rejecting this one, the claim becomes false. And we restate, we write down, there is not enough evidence to support the claim that company A's yogurt cups contain on average less calories than that of its competitors. Let's calculate the p-value for the test of a previous part and make a decision. Obviously, the p-value for this is the area to the left of test statistic. So area to the left of test statistic, t equals negative 2.3901. Degrees of freedom is 39. And we want to find it in a table. We don't have it. So what do we notice? So this is the, again, limitation of space. I'm just showing you on the left column. We are using degrees of freedom of 39. So this number doesn't exist, but look at the positive one is between these two. Okay. And this is area in one tail, by the way. So if the number we want does not exist, again, limitation of a table, if you go with technology, it gives you the answer. You are going to say, okay, it's between these two areas. So degrees of freedom is 39. The number that we have is between these two numbers. Of course, this is negative, so we make them negative, okay? And so the area is between the two. And as you know, the p-value is between 0.01 and 0.025, regardless of what it is, definitely larger than 0.01. Same decision, failed to reject. Remember, the p-value is larger than alpha. Same decision, failed to reject the null hypothesis. Therefore, the claim is false. Decision is in agreement with the previous. Now, here's what it becomes interesting. Let's use technology. I want to show you what happens with technology. So we are going to use two sample t-test. When we do that, we put in x1 bar, s1, n1, x2 bar, s2, n2. We put all the information. So this table, we basically put it in. Now, here's the question that asks you, are you going to pull? So I'm going to use the pull test statistic? Absolutely not. Okay. When you have equal variances, you do that. But they said they use different variances. And they don't even have to say that. You always say no unless they mention there are equal variances. Having said that, you do the calculation. Here's what you see. What is this? This is the degrees of freedom, not 39. So how did they come up with that? Calculator results are different. Since degrees of freedom has a different value. Here's the formula. Degrees of freedom is a plus b quantity squared over a squared over n minus 1 plus b squared over n sub 2 minus 1, where a is s1 squared over n1, b is s2 squared over n2. As you can see, it's pretty complicated. That's why we go with the easy way out. And if you look at the p-value here, 0.0096, it's less than alpha of 0.01, and we're going to reject H0. So calculated result will be different. So you want to be careful with that. Okay. As long as you show work, we can always check it and see what we can get as far as partial credit is concerned. Make a 98% confidence interval for the difference between the two means. Okay. So first and foremost, when alpha is 0.01, for a two-tailed test, it corresponds to 99% confidence interval. However, for a one-tailed test, doesn't matter left or right, corresponds to 98% confidence interval because the entire alpha 0.01 is on one side. So you can think of it as another 1% here. That's why this becomes equivalent to 98% confidence interval. So I want everybody to understand that. So having said that, it's very simple. We have the formula similar to what we had for one sample, x1 bar minus x2 bar plus minus e. So I want to remind you of this. The numerator is x1 bar minus x2 bar. And well, now we're going to calculate the e. So what is the formula for e? T alpha over 2 squared of s1 squared over n1 plus s2 squared over n2. First and foremost, for the t, we have the same number, 2.426. We're going to write the positive because it becomes plus minus here. And this one, do we have to calculate it? No, take a look at these two are identical. Meaning, since I have done this already, I do have the denominator. So I'm going to use this number for t, and I'm going to use the denominator for this one. I don't have to recalculate anything. So the point is, calculation becomes extremely simple. So having said that, we end up, and that's the t. That's the square root. Putting them together, we get this number. So, and the numerator is x1 bar minus x2 bar. Please understand the numerator is x1 bar minus x2 bar. So minus 3 plus minus 3.04504. And we end up with mu sub 1 minus mu sub 2 between these two numbers. Negative 6.04504 and positive 0.04504. Again, this is one way to report it. This is another one. Which way do you report it? The way they ask you. And obviously, what happens, confidence interval contains 0 because it goes from negative to positive. Because the confidence interval limits contain 0, there is not a significant difference between the two means. Fail to reject the null hypothesis. Now, let's do calculated part again. Two sample t interval, and it says pulled again. No, plug in all those values. The only thing that is different here, what is the confidence level, is 98% or 0.98. Take a look at the answer here. The answer here, both sides are negative, so that means you have to reject the null hypothesis. If both sides have the same sign, negative or positive, doesn't matter, 0 is not included. In this case, you reject the null hypothesis. And again, degrees of freedom is, I hope you remember in the previous page, we had this, which was calculated using the complicated formula. df was a plus b quantity squared over a squared over n minus 1, n1 minus 1 plus b squared over n2 minus 1. That was the formula. That's why we then use that. And so calculated results are different since df, degrees of freedom, has a different value. Because the confidence interval limits are both negative and do not contain 0, there is a significant difference between the two means. Reject the null hypothesis. Now, we're going to look at the same question if the carriers of the yogurt cups for company A and company B have equal variances. Please bear in mind, we never use this unless they specifically mention that. So if you don't see that, you assume that the variances are different. You should always assume different variances unless otherwise mentioned. And I can't emphasize this enough. So having said that, what happens is that the first part is identical. H0 mu1 is equal to mu2. H1 mu1 is less than mu2. Left tail test claim. There's nothing brand new. So what happens here, the test statistic has a different formula here. T is x1 bar minus x2 bar over the square root of sp squared over n1 plus s sub p squared over n2. S sub p squared is called pooled variance. Because we are assuming equal variances, we take the weighted average in essence. Okay. So having said that, we're going to plug it into this formula, n1 minus 1 s1 squared, so on, plus n2 minus 1 s2 squared over n1 minus 1 plus n2 minus 1. And we end up with this number, 33.8267, just for the sake of argument. If n was identical, you would, for s sub p squared, you would square this one, add them up, divide by 2. Okay. So you would just take the average. But that's not the case. This is weighted average because n1 and n2 are different. Having said that, now test statistic can be calculated. I'm going to put this into this formula. As I've mentioned, this comes from what? And so you calculate, you get this one. A critical value alpha is 0.01. Now, degrees of freedom is now, because we are using equal variances, add them up, 50 minus 1, 40 minus 1, or 50 plus 40 minus 2. Okay, and we get 80. Now, this one, the answer is 88. Why I'm saying 90? If you go with the table, limitation of table, you don't have 88, you can go to the closest. Okay. And the table gives you this number. Let's do the drawing. And critical value T is negative 2.368, and test statistic of negative 2.4316 is way into the rejection region. So you're going to reject H0. So reject H0 because the value of test statistic is inside the rejection region. So if we go back here, if we are rejecting H0, we are not rejecting H1, we are accepting H1, and claim becomes true, and we restate. There is sufficient evidence to support the claim that Company A's yogurt cups contain, on average, less calories than that of its competitor. So that's how you reinstate the part. Now, same question, we want to calculate the p-value. So the p-value is the area to the left of test statistic because it's a left-tail test. Okay. So degrees of freedom, we said we're going to go with 90 because we don't have 88. So in table has 80, 91. Some tables you can find them online that they have it. And so T is negative 2.368. That is the critical value. Test statistic is negative 2.4316. And we don't find them here, but it's between these two numbers. So between 2.632 and 2.368. The negative is also between those two. And this is one tail test. So the area in one tail is between these two numbers. So the p-value, as a result, is between these two numbers. Again, limitation of a table. Whereas alpha is 0.01, the p-value, no matter what, is less than alpha of 0.01. Same decision as part A, reject H0. And we're done with that. As far as technology is concerned, see, we write exactly the same thing. Where the question is, it's a pooled variance, yes. So pooled, yes. Pay attention to this. This is called two-sample t-test, and you put in all the information. Now you do the calculation. And when you do that, take a look at what happens here. As you can see, degrees of freedom is 88, which is very close to ours. Therefore, the result will be close. And here's the p-value, which is 0.008. If we stop at 5, is 5. And that's definitely less than alpha of 0.01. And we have the same decision, which means reject H0. We continue going to make a 98% confidence interval for the difference between the two means. As I mentioned before, again, a 98% confidence interval for one tail test, doesn't matter left or right. Think about it. Put another alpha here. So this corresponds to 98%, which means you use the same t value that you had in the previous page that you came up with the critical value. So having said that, We want x1 bar minus x2 bar plus minus h. And E is T alpha over 2 square root of S sub P squared over N1 plus S sub P squared over N2. The purpose of that, again, is to limit the amount of calculations. We are going to use the same T that we used here. And this, recall that test statistic was Z equals minus 3 over 1.23376. This was test statistic. So we're going to use this T and we're going to use this one for this part. Reminding you, this is identical to this one, right? And this is identical to this one. And the answer is 2.9216. So in this case, x1 bar minus x2 bar, again, same numerator, negative 3 plus minus 2.9216, or mu1 minus mu2 is minus 3. Subtract this number, you get this one. Add this number, you get this one. Notice both sides have the same sign. It doesn't matter negative or positive, okay? Because 0 is not included, you reject the null hypothesis. Actually, because both of them are negative, it indicates mu1 is less than mu2. If both of them are positive, that means mu1 is larger than mu sub 2. Having said that, because the confidence interval limits do not contain 0, there is a significant difference between the two means. Reject the null hypothesis. Now, if we go with technology, two sample T interval and pooled yes, okay. And of course, we're talking about 98%. Look at the result. This one. Again, we use more decimals in these calculations here. That's why it's slightly different, very close. Minus 0.0766. Again, the difference is because they use a lot more decimals than we do.